This is a lunar launch pad under construction, and it will serve as humanity's gateway from the moon to the rest of the cosmos on its ambitious 2055 project. The journey to build this monumental facility began long before the first lunar module touched down. Decades of research, planning, and testing on Earth laid the foundation for what is now the most daring engineering endeavor of our time. Mankind was born on Earth but has always dreamed of reaching beyond, and the decision to erect a state-of-the-art launch pad on the moon was a declaration that humanity was not meant to be earthbound. In the early months of 2055, with the facility's design finalized and the massive components already assembled in orbit around the moon, a new phase of operations commenced. A series of unmanned cargo landers, guided by precision robotics and aided by AI-driven control systems, began transporting prefabricated modules to the lunar surface. These modules were engineered to withstand the moon's harsh environment, extreme temperature fluctuations, micrometeorite bombardments, and pervasive regolith dust that threatened the integrity of even the most robust materials. Each module was meticulously designed in a cleanroom environment on Earth, then packaged and launched aboard heavy-lift vehicles. Once they reached lunar orbit, they were redirected by gravity-assist maneuvers and landed with pinpoint accuracy at the designated site near the lunar South Pole. As the initial modules touched down, the surface, a desolate silver-gray plain scarred by ancient impacts, was slowly transformed into a futuristic construction site. Automated excavators, built to operate in reduced gravity, began the delicate task of clearing the landing area and preparing a stable foundation. Engineers on Earth monitored every movement with real-time data feeds, their screens filled with high-resolution images and telemetry readings that detailed every micron of movement in the lunar dust. The first phase of the launch pad's development was to create a level base on which the entire structure could be built. Robotic graders and vacuum-based regolith collectors combed the surface, ensuring that every obstacle was removed before the massive support pillars were anchored into the lunar crust. The launch pad's primary structure is composed of interlocking panels made from advanced composite alloys and lunar regolith-derived concrete. These panels, developed over years of research into in-situ resource utilization, offer both strength and resilience. The composite panels are designed to absorb and dissipate the shock of rocket launches, while the regolith concrete, fired in solar kilns set up on the lunar surface, ensures the building material is both sustainable and perfectly suited to the moon's environment. Once the foundation was prepared, robotic cranes and assembly arms, larger than any seen before in space, began lifting and interlocking these panels into a rigid grid that forms the skeletal frame of the launch pad. Over the next several weeks, the construction site buzzed with activity. Autonomous rovers transported massive trusses and support beams from the landing zone to the assembly area, and overhead a sprawling network of power cables and optical fiber links connected every module to a central command hub. The hub, located at the heart of the facility, was built to serve as the nerve center for all operations. It houses arrays of quantum computers that process data from hundreds of sensors, spread throughout the launch pad and its surrounding area. These sensors constantly monitor structural integrity, temperature gradients, and even the subtle shifts in the lunar surface that might indicate seismic activity caused by meteorite impacts. The command hub's design incorporates a spherical atrium where engineers and visiting astronauts can view a holographic representation of the entire facility. This 360-degree projection updates in real time, displaying the progress of construction, the alignment of support structures, and even the minute vibrations detected within the lunar bedrock. By combining cutting-edge holographic displays with artificial intelligence, the system not only provides a visual feast for its users, but also acts as a diagnostic tool, warning of potential faults long before they become critical. The hub's design was inspired by Earth's most sophisticated mission control centers, but it has been adapted for the unique challenges of lunar operations. Meanwhile, the construction process had to contend with the moon's notorious fine dust. Lunar regolith, abrasive and electrostatically charged, has the ability to cling to surfaces and infiltrate mechanical systems. To combat this, every robotic system and assembly module was outfitted with specialized dust-repellent coatings and self-cleaning mechanisms. High-pressure jets and electromagnetic scrubbing systems were routinely activated to clear the delicate optics and joints of the assembly machinery. Engineers had calculated that even a few microns of dust accumulation on critical components could degrade performance and lead to costly repairs or delays. As such, a regimented maintenance schedule was established, with robots programmed to conduct thorough cleaning cycles after every major phase of construction. As the skeletal frame of the launch pad began to take shape, additional infrastructure modules arrived. These included fuel storage depots, maintenance bays, and habitation pods intended for the construction crew and future mission support teams. The fuel storage depots were constructed with a dual-layer design. An outer shell of regolith-based concrete provided shielding from cosmic radiation and meteorite strikes, while the inner compartment was lined with a reflective polymer that minimized heat absorption during the long lunar days. These depots would later be used to store not only traditional propellants but also cryogenic fuels destined for deep space exploration missions. The habitation modules were a marvel of modern engineering. Each unit was self-contained and fully equipped to support a small crew for extended periods. They featured life support systems that recycled air and water with near-perfect efficiency, laboratories where experiments in reduced gravity could be conducted, and recreational facilities designed to provide a semblance of home in the alien environment. Interior walls were adorned with digital art that changed with the lunar cycle, reminding inhabitants of the rhythmic passage of time despite the station's static location on the moon's surface. These modules were connected by pressurized tunnels that allowed crew members to move between different sections of the launch pad without the need for bulky spacesuits. With the core structures in place, the next phase of the project was to integrate the launch control systems. This involved installing a network of communication arrays, radar systems, and tracking sensors capable of coordinating the complex dance of rocket launches. The arrays were designed to cover an enormous swath of space, tracking objects from low lunar orbit to interplanetary trajectories. A series of phased array antennas, mounted on adjustable pedestals around the periphery of the launch pad, would allow operators to lock onto the position of a spacecraft from the moment it lifted off. These antennas, with their rapid electronic steering capabilities, could adapt to the dynamic conditions of a rocket's ascent, providing continuous updates on its status. To ensure the safety of every launch, the facility was also equipped with an advanced early warning system. This system uses a combination of LiDAR, radar, and optical sensors to detect any incoming debris or unexpected anomalies in the flight path of a rocket. If an object was detected that could pose a threat, the system would automatically initiate countermeasures, ranging from the deflection of small debris by targeted laser pulses to the rapid shutdown of non-critical systems in the event of a larger impact. Every component of this network was integrated with the central command hub, ensuring that every decision was made with the most up-to-date information available. As construction progressed into its third month, engineers began the delicate task of testing and calibrating the various subsystems. One by one, the modular segments of the launch pad underwent rigorous evaluations. Robotic test units simulated rocket launches, generating controlled shock waves to test the structural resilience of the platform. Vibration dampeners and shock absorbers, hidden within the composite panels, were fine-tuned until they could dissipate the tremendous forces generated by a fully fueled rocket liftoff. Every test was logged and analyzed by AI systems that compared the data against thousands of simulations run on Earth-based supercomputers. These tests were critical, as even the slightest miscalculation could prove catastrophic when dealing with the explosive energies of rocket propulsion. During a series of comprehensive system checks, the facility's communication links were also put to the test. Engineers transmitted real-time video feeds and telemetry data from the lunar surface back to mission control centers on Earth. Despite the roughly 1.3-second communication delay, the result of the moon's average distance from Earth, data flowed seamlessly between the two worlds. The exchange of information was so smooth that the engineers jokingly remarked that the moon was just a stone's throw away, even though the technological hurdles had been monumental. This robust communication network would prove indispensable not only during construction, but also in coordinating future launches to the solar system and beyond. With the launch pad nearing structural completion, attention turned to the aesthetic and functional integration of the facility with its lunar surroundings. Architects and engineers collaborated to create a design that would minimize visual disruption to the pristine lunar landscape while maximizing operational efficiency. The exterior of the launch pad was clad in a reflective, moon-white material that blended with the natural regolith, almost camouflaging the facility from casual observers. Yet beneath its subtle exterior lay a labyrinth of high-tech systems, each critical to the pad's mission. Outdoor pathways were lit by energy-efficient luminescent strips, powered entirely by an array of solar panels that tracked the sun's arc across the lunar sky. These panels were engineered to tilt automatically, optimizing exposure during the lengthy lunar day and then folding away as the long, frigid night approached. The solar arrays, arranged in a series of concentric rings around the facility, were linked directly to massive battery banks housed in underground bunkers. These banks stored energy harvested during the day, ensuring that the pad's operations could continue unabated during the approximately 2-week-long lunar night. To further safeguard against power interruptions, a series of compact nuclear reactors, small modular reactors designed specifically for lunar applications, were installed as backup generators. These reactors provided a steady, reliable source of power, independent of the sun, and were shielded with layers of regolith-based concrete to protect both the facility and its inhabitants from radiation. As the year 2055 advanced, the focus shifted to final system integrations and rehearsals. Engineers began conducting full-scale simulations of a launch sequence. These dress rehearsals involved every component of the facility, from the rocket fueling systems and launch control centers to the emergency shutdown procedures and post-launch recovery operations. During these simulations, a prototype rocket, affectionately nicknamed the Silver Arrow, was used to simulate a liftoff. The Silver Arrow was not destined for deep space but rather served as a testbed to validate every aspect of the launch pad's design. In one memorable simulation, the Silver Arrow ignited its engines with a controlled burst of energy, lifting off the pad in a carefully choreographed sequence. Sensors recorded every moment, from the initial ignition flash to the final separation of booster stages, and the data was scrutinized to ensure that the pad could handle the real thing when the time came. During these final tests, the Launch Control Center became a hive of activity. Technicians monitored an array of screens displaying telemetry data, high-speed video feeds, and three-dimensional models of the rocket's trajectory. A calm, measured voice guided the crew through every step of the process. Engines at full thrust, trajectory nominal, all systems green. The success of these tests was a testament to years of painstaking research and engineering. The human element of the project was never far from the minds of the mission planners. While much of the construction was automated, a dedicated team of astronauts, engineers, and support staff had been stationed on the lunar surface to oversee operations. These pioneers lived in a cluster of interconnected habitats adjacent to the launch pad. Their daily routines were a blend of scientific research, engineering maintenance, and even moments of quiet reflection as they gazed out over the vast, unyielding lunar horizon. Life on the moon required discipline and resilience. Every day was a reminder that the environment was as unforgiving as it was inspiring. Yet in the face of adversity, these men and women had found a way to thrive, their efforts marking a turning point in humanity's journey to become an interplanetary species. As the countdown to the first operational launch began, the launch pad was gradually transformed from a construction site into a fully functional spaceport. Dedicated facilities were established for the final fueling and servicing of spacecraft, and specialized hangars were built to shelter and maintain the rockets that would soon carry explorers and cargo beyond the moon. The entire project had been a collaborative effort spanning multiple nations, private enterprises, and academic institutions. Engineers from around the world had contributed their expertise, pooling knowledge and resources to create a facility that would redefine the limits of human exploration. The launch pad was not just a testament to technological prowess, it was a symbol of unity, of what could be achieved when humanity worked together toward a common goal. With the structural, electrical, and operational systems integrated and thoroughly tested, the facility entered its final phase commissioning. Over a series of days, engineers and technicians conducted rigorous safety checks, calibrated the final instruments, and ran redundant tests to ensure every system performed flawlessly under simulated launch conditions. These tests included emergency drills where power failures, communication outages, and unexpected system errors were introduced into the simulation. The facility's response was immediate and coordinated, a dance of automated responses and human oversight that underscored the pad's resilience. Every anomaly was logged, every glitch corrected, and every procedure refined until the facility was deemed ready for its inaugural launch. The commissioning phase also included a series of public demonstrations. Live feeds were broadcast back to Earth, showing the launch pad in all its high-tech glory. Citizens from around the globe watched in awe as the lunar facility, bathed in the pale light of the Earthrise, underwent its final checks. These demonstrations were not only technical validations but also powerful symbols of hope and progress. They represented the culmination of decades of work and the promise of a future where the boundaries of Earth were but stepping stones to the wider universe. In the final hours leading up to the launch, tension and excitement were palpable both on the lunar surface and back on Earth. The facility's control center, abuzz with activity, became the stage for the final countdown. Every subsystem was reporting green, and the holographic displays in the command hub glowed with the reassuring data of a project nearing completion. On the lunar horizon, the silver-white panels of the launch pad stood ready, a beacon of human ingenuity against the barren backdrop of space. At exactly 1745 lunar time, the first fully fueled and operational rocket was positioned on the launch pad. A deep, resonant hum filled the control center as engineers initiated the final pre-launch sequence. The rocket's engines ignited in a controlled burst, and a brilliant plume of light erupted from its base, casting long shadows across the lunar regolith. This was the moment that decades of planning, testing, and tireless work had been leading to. The rocket ascended slowly at first, its trajectory meticulously monitored by the facility's state-of-the-art tracking systems. Within minutes, it was clear that everything was operating exactly as designed. The successful launch was more than a technical achievement. It was the symbolic opening of a new chapter in space exploration. The lunar launch pad had proven itself not only as a marvel of modern engineering, but also as a beacon of humanity's enduring spirit of adventure. As the rocket continued its ascent into the depths of space, the engineers and pioneers on the lunar surface began to prepare for the next phase of operations. Future missions, both manned and unmanned, would use this launch pad as their staging ground, embarking on journeys to Mars, the asteroids, and even further into interstellar space. In the days following the inaugural launch, the lunar facility entered a period of heightened activity. Routine operations were expanded to include maintenance flights, cargo transfers, and even the testing of new propulsion technologies. The launch pad's design allowed for rapid reconfiguration, so that between missions, the facility could be adapted to support diverse types of spacecraft, from agile, reusable shuttles to massive, deep space exploration vessels. Every successful launch further bolstered confidence in the design and operation of the pad, and engineers continued to refine procedures based on real-world data. The feedback loop between operational experience and engineering design became a key factor in driving continuous improvements, ensuring that the facility would remain at the forefront of space launch technology for decades to come. As the lunar day gave way to the long, cold night, the facility's backup power systems kicked in seamlessly. The nuclear backup reactors and battery banks maintained a constant flow of energy to critical systems, ensuring that communication links with Earth remained uninterrupted, and that automated systems continued to monitor the structural integrity of the pad. Even in the absence of sunlight, the facility shone with the quiet efficiency of human ingenuity at work. Technicians in the command center reviewed the day's data, preparing detailed reports that would help refine future operations. They analyzed the performance of every subsystem, from the vibration dampers that had withstood the forces of rocket liftoff, to the precision-guided robotic arms that had assembled the massive composite panels. Meanwhile, on Earth, mission control centers around the globe celebrated the success of the lunar launch pad. International media outlets broadcast images of the facility, emphasizing its sleek design and its promise of a new era in space exploration. Scientific journals published detailed reports on the technological innovations that had made the project possible. Universities organized symposiums and public lectures to discuss the implications of this breakthrough, and the project soon became a unifying symbol of global cooperation and progress. In many ways, the lunar launch pad represented the culmination of centuries of dreams and the beginning of a future where the limitations of our home planet would no longer define us. With every passing day, as more launches were conducted and more data gathered, the lunar launch pad continued to evolve. Engineers introduced incremental upgrades to the control software, refined the algorithms that guided the autonomous construction robots, and even retrofitted certain modules with enhanced thermal insulation to better withstand the moon's extreme temperature swings. Each modification was implemented with the knowledge that the facility was not just a static piece of infrastructure but a dynamic, living system, one that would adapt and improve with every mission. By mid-2055, the launch pad had firmly established itself as the primary hub for lunar operations. Its myriad functions, from fueling and maintenance to crew preparation and mission planning, were fully integrated, and the facility's design had already inspired similar projects on the lunar far side and even at strategic locations in orbit around the moon. As humanity prepared for the next great leaps into the unknown, the lunar launch pad stood as a testament to what could be achieved when creativity, technology, and determination converged in pursuit of a common goal. In the final analysis, the story of the lunar launch pad is not just about concrete panels, robotic arms, or quantum computer systems. It is the story of a species reaching out from its ancestral home to grasp the infinite possibilities of the cosmos. It is about overcoming challenges that once seemed insurmountable, adapting to an environment that was once thought too hostile for human endeavor, and turning those challenges into opportunities for innovation and progress. Every bolt tightened, every sensor calibrated, and every system integrated has contributed to a legacy that will propel humanity into a new age of exploration and discovery. As the year 2055 draws to a close and the lunar launch pad continues to operate with unwavering precision, the dreams of 1,000 generations echo in the silent vacuum of space. The facility is not merely a launch pad, it is a bridge between worlds, a symbol of unity and perseverance, and the first stepping stone on humanity's journey beyond the confines of Earth. With every launch that lifts off from its surface, the pad sends a clear message. Our destiny lies among the stars, and nothing, not even the harshness of a distant lunar landscape, can stop us from reaching out and embracing it. The lunar launch pad stands ready, its gleaming structure a fusion of human innovation and the timeless beauty of the cosmos, inviting all who dare to dream to join in the next chapter of our shared adventure into the unknown.